Welcome to Display Week 2026. I'm Michael Loftus. I'd like you to welcome us to the Smart Cockpit 7.0. What we're looking at here is a wood simulated finish. It actually has a wood texture touch. There's actually a display under here, so if I was to touch this, we could light this up. It wasn't actually visible until I physically touched this. There's a touch screen here, and when I turn it off, you'll get once again see that it is invisible. So we call this our InvisiView display. This could be anywhere on the display. We put it in the armrest for this application. As we move up, we have a 17-inch flexible OLED, which has a 7.5 millimeter radius. So right now it's in the infotainment mode, right? And when I press a button on the dash, we can go into the entertainment mode. It'll actually roll up out of the unit. This has a touch already built onto it. So if I was to touch it, it will roll down. So it's a 17-inch flexible OLED display, high resolution, flexible. We have other 17-inch displays in the back of the cockpit, which is fixed on a fixed unit. So it's got an actual glass back, it has a backing here. And we can actually put these in different bend radiuses as well. So if we want to put this on the dash, if you want to have a dash, we can actually do cold bending with Corning glass. We're really showcasing here is a 49.6-inch curved Acronis display. This is actually two displays. It has a nice 300 millimeter bend radius. It looks as one contiguous display. It's got a great field of view in the sense of you're not seeing a lot of reflection up here in the windshield. It's got a great field of view left and right and limits the view up and down so it's not bouncing off there. That's one of our highlights to showcase here. To Tianma's Display Week, and we're looking at our safe driver applications. We're looking at a 43.7-inch display. It's got a nice wide view. It's 50 degrees left and right, and it's about 2.5 up and down. It reflects off of here off the display, so you can't see through it. But this is on a AMOLED, and it's on a cold bend. So with that piece of glass, that means the actual OLED device is bent on the glass and held in its position here. This here is 10,000 nits of brightness, which is much higher than the competitors out there. We're looking at here our next display. This is three 11.98 OLED displays. So there's actually three displays. It looks like one display because it's all connected. This has got a great field of view of minus from 40 to the left and right and 5 up and down. And it's got a great field of view. And it's 12,000 nits. Most displays are only, competitors are operating at 8,000 nits. This one operates at 12,000 nits. One of the things I'd like to highlight is our new 12-inch micro LED. This display here is higher than most normal displays. It's at 120,000. Most displays we typically see are 300 nits. This is 120,000 nits. So extremely high peak luminance. This is actually going right up as a heads-up display. You can actually see through the display, and it's extremely bright. So if the ambient light was to come in, the sunlight, you would still see it no matter what the lighting conditions were. I'm going to be walking through some of the integrated experiences starting off with our 12.3-inch wide field of view 3D cluster. We're working in cooperation with C-Cubic and Tianma to co-develop this. This provides a nice integrated experience with the 3D visual. It does not have eye tracking, so that's one of the unique things about this. It has an integrated experience. It has 500 pixels per inch. It's a great automotive application. Moving on to our 12.3-inch full camera display. So what we have is almost a full HD display here. We put a high resolution camera in there, 2 megapixels. It has the ability to do facial recognition, also determine if you're smoking. So it's got a great camera. It's working on near infrared at 940 nanometers. So if in a rental vehicle, you could basically capture if someone's smoking and who was smoking with the facial recognition. Moving on to our switchable display, stay right there. This display has a nice wide field of view, but with the new automotive standard, they're restricting the field of view to less than 35 degrees. So everybody was doing 45 degrees. We've changed this, so when I hit the switch, you'll notice from one angle, it'll no longer be visible on this side. So when the passenger's on this side, when you start, the driver will no longer be able to see it after an angle of 28 degrees. So great field of view, but once the driver gets going, it stops. Moving on to our 17.3 inch. This is an integrated display. It will have a ambient light sensor. It goes from 0 to 100,000 lux, and it's accurate up to 2. We integrate ambient light sensor right at the bottom there. You can see it's already up at 1600, but when I touch it right here, it'll drop, knowing that it can't see the light. And it also has color temperature, which is unusual for an ambient light sensor when you do the outside one. Also, you'll notice that it has a very, very narrow border, and when we have this narrow border, and because it is a touchscreen in there, we have the ability on the FPC to add a NFC, so for near field communications. So highly integrated, very thin display, very narrow border. All of these displays will have a wide temperature range from -30 to 85 C. Also, they'll have the liquid crystal material that goes from -40 C to 110 C for clearing point and freezing point. And moving on to our 10.1 inch narrow border touch-enabled display. That's an in-cell touch. It's operating at 120 Hertz. This is an excellent display because by having a higher frame rate, it allows you to also drive the panel a little bit harder. It will not have any image sticking, and we test this for 1,000 hours. Typical testing is roughly 240 hours. We're testing this at 85 degrees for 1,000 hours, so this has gone through a lot of testing. So it has a touch on there, so it is very, very good for automotive application. Once again, it's got the high reliability. We're going to be talking about the in-flight and transportation segment. We're going to start off with our 28.6 inch display. It's a half full VGA, so it's 1920 by 540. This has a wide temperature range because it's going to be an outdoor environment. It'll go from -35 to 85 C temperature, operating temperature, but the liquid crystal can go all the way to -40 to 110. And the polarizer on there is a 95 degrees C. That's not typical for most display applications, so you will not have any issues with the display going black on you. So this is great because it could fit above a transom in a train, or it could be used as some type of signage over a door. And we'll move on to our 13.3 inch, which is great for high-end medical and in-flight entertainment, IFE. So it's a 13.3, 2K by 4K. This has mini LED. When I say mini LED, there's an array of LEDs in the back, and it has a contrast ratio of 1,000,000 to 1. So when you look at the blacks are actually very black because we're lighting up specific zones. We have 1,536 zones illumination. Moving on to our 23.8 inch. This is also a mini LED, so there's a lot more dimming zones on this one. This has 2,306 dimming zones on this. The blacks are super black, and it's 4K by 2K resolution as well. Very high contrast, 1,000,000 to 1. What's unique about this next 23.8 inch, it is more targeted at specifically at the marine environment, because the marine environment is much more stringent because of the outdoor environment where they're going to need a minimum brightness. This here has 1,800 nits of luminance, and it has a high resolution. It also has dimming zones, so it's high contrast, high uniformity. If you're looking at the blacks, they're deep saturated blacks. When I fold this up, I'm going to allow you to look inside. So at a nighttime application, you'll be able to see that you will not have any of those hot spots that you would traditionally see at night as you look through this. So you know how when you look at some of the displays, you get some white spots at night that you won't see during the day. We're looking at our high precision medical devices. Here we're showcasing a 4K by 2K display. It's running at 140 Hertz, so very high refresh rate. You can see high resolution, so as you're looking at the images, high contrast as well. Beautiful display for diagnostics. And what we'd like to highlight today at the SID is our new multi-zone 2D, 3D display. This allows you to have 3D over here and 2D here, and there's no loss between the 2D and the 3D. We're using an eye tracking, so as you move around where you're a couple of feet away, you'll actually see that it's able to track your eyes and rotate the image, so you'll actually have a great 3D experience. Well, moving on to our narrow border, This is our 23-inch full HD high resolution display. It is an extremely narrow border, very narrow on this panel. And as we move on to our 27-inch quad high def display, this is an oxide display. Oxide means it has a really high refresh rate. This one here will go from 20 to 140 hertz. So a larger dynamic range. So if you're working on a Word document, you'd operate it at the 20 hertz frame rate, whereas if you're looking at a full motion video monitor, this would be for gaming. You could use this as well. So great, wide, diverse, lower power when you're operating at 20 versus the 140. Then we move on to our notebook display. This is a 16-inch wide QXGA display. This is, once again, has a wide dynamic refresh rate. This is an oxide display, and this operates from 1 hertz all the way up to our 20 hertz, 120 hertz. Moving on to our 16-inch wide UXGA display. Has an in-cell touch, so it makes it much thinner because there's no added layer. By also making it an in-cell, there's about a 20% cost reduction on this. This is one of our notebook applications. You can see here that it works as well. Moving on to our next one, which is our 14-inch, which is a resolution of 2.8K in-cell. It operates 120 hertz, so a very, very high refresh rate. What's unique about this, it's also in-cell touch, but it also has the ability to work with the pen, and the pen has multiple buttons, so you can activate different things. So if you want to create different applications, zoom in, zoom out, you can do that. So it has a tablet in the back. So once again, great application for that. We're looking at our 14-inch ePrivacy display. This ePrivacy display, when you're standing in front of it, you can actually see it, but when you get off at an angle, you'll see that nobody else is able to see it, what you were looking at other than the logo. So that's programmable, that we use an e-cell on this device. Once again, anybody off at an angle will only see a logo. They won't see what you're looking at. We're looking at a 12.8-inch all oxide AMOLED display. So really nice field of view. And this also has a dynamic range as well, all the way from refresh rate from 1 to 240 hertz. So very, very high dimmable frequency range, so low power as well. And it's got great NTSC. It's great for a notebook application. Moving on to our video and commercial. These are targeted at 24/7 applications. These always have to be running. They're operating at minus 30 to 85 degrees C. High reliability applications for commercial use. This is an SFT, meaning it's got an 85-degree viewing angle from left to right, up and down. And then we also have our 21.5-inch full HD, so 1920 by 1080. Operating the portrait. These also can be set up as a landscape mode as well. So great field of view, great application, running at 24/7 applications. This here we have is our color BCN. This is a reflective display. So once you set the image, it will be there at 0 power. You will not have to use any power. So if you were at a restaurant and you want to put up a menu board and set it for the day, you will not have to refresh it. It'll be there the whole day. Or as a bus stop application, you could put it as there for some signage and leave it there for weeks. We will not have to change it. It'll run at 0 power, so you won't have to be updating it all the time. We're talking about a lot of our smart mobile devices. What's unique about these displays, this is a 6.78-inch OLED device. What is unique is about this, it uses the BT 2020 standard for color. How do we achieve this? This is achieved by using higher purity materials. We use better green materials. It has green lighting emitting and red lighting emitting. So you can see the higher color saturation versus this normal OLED device. So much higher, much more efficient, much brighter, great color uniformity there. And then we're looking at the difference between a stacked OLED and a normal display. So using a stacked OLED, there's 2 OLED devices, one behind the other. So it's a tandem, and you can get higher luminance at less power versus the normal. So much more brighter display. So here we are. These two displays are full screen displays. A lot of the displays, when you have the capability of making them brighter, they say they go with a high peak luminance. They're talking about a small area of the display. This here is a full screen display. We can actually bring the luminance up much, much higher, so it's it's a full screen. This also has a high refresh rate, a 240 hertz refresh. So it also has a very, very narrow border. So very, very small. So it's 0.35 border and a 0.5 millimeter overall module border. So if you want to vote for this here at the show, we'd love you to vote for this. This is new technology for full screen display. Once again, it's the whole screen could be hybrided. We're looking at our new 6.58 U11 display. It's an AMOLED. So what we're doing is we're using our NFT technology, which uses a low blue light. And so we basically take that, the new fluorescent technology. So it's basically two technologies where you use the new fluorescent blue phosphorescence. So basically getting the singlet and triplet emissions of this device, so to get the color out of there. So we're talking about a 6.78 inch display. This is a non-dispersible color on TFT. So these are all touch displays. What happens is this non-dispersible, so as you look at a display, most people using displays a long time, this here has direct drive dimming, whereas this would have pulse width modulation, so you would see like vertical frame rate. Now, your eyes typically won't see that in your head because it does the averaging, but it creates eye fatigue, so it won't be very eye friendly. So this becomes much more eye friendly when you have non-dispersive direct drive. We're looking at a 6.78 gray level AMOLED. What this is, we're able to remove a polarizer on the front of this LCD. So a polarizer is needed on an OLED device. So because of the light coming in, it reflect out and you wouldn't see all the colors. So to get a good color balance, you would need that polarizer. So, but once you put a polarizer, you have a lots of luminance. So what we did on this one, we removed the polarizer, we add the gray layer, which has a black mask. It allows all the light to come out now, so it's much less power for the same luminance. We're talking about our 6.9 inch creaseless display. So these both displays have been bent the same amount of time, and if most of the displays, you can feel a curve. I don't know if you can come over here, but you can see that there's an indentation on this. And whereas this one is our creaseless display. So how do we do this? We have a new structure for the material. It's a water drop structure as a water drop. So as you put water drops together, they would be able to have a much easier time bending. So it would be less of a crease in the device. So it's much, much easier for this to be a creaseless display. Then we're looking at our 6.7H, which is our COG 2.6 millimeter radius, very small edge, narrow borders. It's about 0.5 millimeter smaller than the competitors out there. It's amorphous silicon device, whereas the other ones we talked about earlier were OLED devices. So this is our amorphous silicon type of OLED amorphous silicon display. This display is our multi-frequency display, so it allows you to run at different frequencies, wide frequency range. You could set up a frequency range here and a lower frequency here. So by changing it from 120 hertz down to 40 hertz, you could get an extra 0.5 hours out of the display. Great advantages. So if I'm looking at a static image, it's great. If I was looking at a video, I'd be running at the higher refresh rate. So great power savings by having different frequencies. 26 booth, we're talking about the Cozy Home display. You may see some round displays here. We're talking about a 1.43 inch or a 1.8 inch and a 3-inch knob and a 3-inch knob. What's unique about each of these, they all have touch capabilities. On this one here, it has a wood grain look, similar to if you were looking at the automotive display. You'll notice we had a simulation where once it's off, you won't see this. And all of these displays have AI capability. So you can program it with your Wi-Fi, hook it up, Bluetooth, Wi-Fi. It has touch capabilities, but it also has a knob. So you can actually physically do some rotation. So if you like the mechanical feel, you can do that. You can do this. It has touch capabilities, and you can see here the color change and a knob capabilities. So moving back here on the Cozy displays, we're looking at a 4.6 inch display. It has the NFC integrated into the display, so if I was to touch down here, nothing would happen. So the NFC, you have to be anywhere from 2 to 3 millimeters away. So when I touch here, you can see that it recognized the credit card. So that's the nice integration. Because we integrate the NFC inside, it reduces the thickness and also the border of the display. We're looking at, once again, one of our InvisiView displays. You saw the wood grain simulation and also had the texture field. We can also do gray, and in this case, we're actually showcasing our marble texture. So it looks like marble. So once again, you cannot tell if the display is there or not. So it is a full display, narrow border, and we have a showcase for the applications where somebody wants white. White has less of a contrast, but you can see that the actual display is there. So it's a white front instead of a black, which is a dead front, or marble, or wood grain. And we're looking at our immersive display technology. We're looking at a tile display, which is 8.9 inch. It's 4 displays on the top and 4 displays on the bottom, so 4 by 2. If one was to go bad, you would be able to pop it out and put a new one in. And so it's a micro LED. It's seamless. You can't tell which ones. It's 8 displays. Very high resolution, great uniformity, nice looking display. Very great for the immersive. And we at our CES we had 108 inch, and this is all laser mass transfer, so it makes it much more efficient for high production. Moving on to our 27-inch quad high def display. This is a 300, great for gaming applications. This is a monitor application for the immersive display technology. So it's very cost efficient. It's an amorphous silicon. It's very difficult for amorphous silicons to be at 300 hertz. Typically we would be gone to a oxide display. I'd like you to see this technology. This is our iFun technology 3.0. Typical displays, you won't be able to see an image. It'll look really black. You lose the contrast. So with iFun, it has with the ambient light sensor and the coatings on this, the ambient light sensor will do gamma adjustments. So if I was to put my finger over here, you would see that the display would change. So you can see the difference between the iFun and our iFun. Looking at our 16-inch wide XGA, it's 240 hertz. It's got an anti-glare, anti-reflective coating on this great display for a notebook application, and it'll be easier on the eye. We're looking at our 7-inch micro LED dual display. When I say dual display, there's one micro LED on this side, and there's another one on the second side. They're optically bonded, and one display is independent of the other. So you could be showing one image here and another one. So if you were in a marine application, you could be showing the boat. On the other side, you could be showing information on it. Or it could be like an Uber application where you put Uber on one side and the driver's information on this side. It's a 7-inch, and it's got a nice resolution of 600 and 480 by 320. Moving on to our 19-inch module. This is a tiling. So we actually have 3 7-inch displays here, and they're tiled to create a 19-inch display. This is a transparent. What's unique about this micro LED display is that with micro LEDs, you have about a 50% transmissivity. When you look through a micro LED, you will see a rainbow effect caused by how the light comes through the display. What we've created through a new black mesh technology is we're able to eliminate that light dispersion and eliminate that rainbow effect. We're looking at the world's first 3.16 micro LED round transparent display. You can actually see through it. Moving on to our 15.6 inch. This is a cadmium-free quantum dot mini LED, so lots of zones here. So quantum dots typically would have cadmium, which has now become part of the restricted RoHS and REACH agreement. So this is cadmium free. As we're looking on to the next display, it's a little bit different technology where instead of a white LED, we're moving to a red, green, blue LEDs. So what we do, because we know what the frequency of those LEDs are, we will tune the color filter to those frequencies so there won't be any waste of light coming out. You'll get the true saturated color. You'll be looking at a higher NTSC, more than 100% of the NTSC. Now we're moving into the BT 2020 color. Once again, 3 colors of mini LEDs. The color filters are tuned for that, so you can get a higher. We're looking at our 29.5 inch low temperature polysilicon in-cell. What's unique about this is typically you would have a lot of driver ICs and a touch controller IC. This uses an integrated touch and driver IC. There's only 2 of them on here. Our closest competitor is 3. So every time you're able to reduce a component, you're able to save money, and it becomes higher integration. So this is 6,000 pixels on the horizontal. So very, very high pixel density. Great application for a 29.3 inch display. Okay, we're looking at our 17-inch white display. And if you look, we've actually separated this so you could have a view of a normal display versus one with a light control information. So if an auto application, you won't want the reflection of your radio coming up or your display on your windshield. So we implemented this light control filter so it doesn't allow the image to limits the field of view up and down. But also at the same time, when you have a high ambient light, you can't typically see your radio. So by having this light control information filter on there, it stops the light from actually reflecting on the display so you can actually see the display. So once again, you can see the reflection here of this display, but you can't see it on this one. As we're moving, it's a switchable privacy display. So it moves from, we're able to change this. If you can come over here, you can see that it has a wide field of view. If I press this button, right, it has a really good wide field of view, and by hitting this button right here, it switches the privacy mode of the display. It's very limited field of view. We're going to have here, we have displays and keyboards now. We have applications where they're in headphones. If you wanted to know if someone was actually busy, you could actually put a note out there saying, not busy anymore. We have pendant applications. This is actually in mass production. Back up. And then we also have applications where in their watches. Another watch, and we also have pendants. So here we have this OLED devices, the circular OLEDs. So we have 3 different displays, all the same resolution, but what's unique about these 3 displays is this is a stacked OLED or tandem display, and this is our multi-lens micro lens pattern. So this panel is showing a brightness, and that this has the same brightness, but you can see that the power is much more here. We're talking about 100 more milliwatts. So every time you add power, it's going to decrease the life of the battery. So by having a stacked OLED or tandem display, it allows you to create the same luminance for less power. And because it has the micro lens pattern, you can get a high brightness mode. So going from 250 nits to all the way up to 4,000 nits. So this one here would have just 2,500 nits, but it uses much more power. So we're looking at an ultra thin. Maybe it would be better to step over to here to this panel first before I talk about the thinning. So we're looking at a 2.07 inch glass OLED. So it's the OLED on side the glass. And what we do with this one, to keep the border narrow, typically with the OLED devices, you need a strong border. And in order to do that, we use a low pressure injection overmold. That overmold material basically stabilizes the FPC in the back of the LCD. So by making it stable now, it creates a more reliable display and allows the thinning so you don't see it has less border. And then we have our plastic OLED. When you have a plastic OLED, you could actually form it to be different shapes, so it could be curved because of the shaping of the material. And then when we're looking at this one, this is an ultra thin. So if we look at most of the displays, they get pretty thick. So what we've done is to decrease the thickness of the display, we actually do some thinning of each of the materials, and we're able to move one layer of the material. So it's ultra thin display OLED device. Want to showcase some of the gaming displays. Here we have a flat one for an application with a nice resolution on that display and high resolution. And this is the same one targeted at the foldable applications. These are great for gaming.